Now, before we go on to the example on page 161, it's worth just looking over a couple of things that we need to remember when we're plotting the graph of a cubic function. So I went over the idea of the shape, that if it ends upwards, it's a plus x cubed, and if it ends downwards, if it ends pointing downwards, it's a minus x cubed. But there's other things to be aware of about the shape of the graph as well. So if I have three different real roots, like I did in the last question here, then it's going to intersect the x-axis at three different points, just like quadratics. And of course it could have either shape with those three. But I could have just 2 points where it intersects the x-axis, and that means that I've got two equal roots at the point where it touches. So two equal roots where it touches the x-axis. And again, I can have my ending upwards shape or my ending downwards shape with that, two equal roots. And the final type is where you only have one real root. Only one real root. And again, you can be ending upwards or ending downwards with each of those. This type here, if you remember how we find the roots of a cubic function, the first thing you have to do is find the first root by trial and error. You try out different values for x, like x equals 0, x equals 1, x equals minus 1, and it will always be within the first three if they've asked you to solve it with no other information. And then you use that to find the factor by changing the sign. And then you do long division, which gives you a quadratic to find the other two roots. So when you only have one root, this quadratic, in this case, has a discriminant, the thing underneath the minus, or the thing underneath the square root, the b squared minus 4ac will be negative. So if you get a minus sign underneath the square root, can't get the square root of a negative number, which means we don't have three real roots and the quadratic part has no solution. So the quadratic part has no real solution. So we keep saying things like this, no real solution. That's because it does have complex solutions. Complex numbers, imaginary numbers. Okay, so that's just a little bit more information about things to watch out for when we're plotting the graph of cubic functions. Let's move on and look at the example on page 161 then. So example 31, we're going to sketch the graph of this function here. So this one is starting with a negative number. So straight away, I know that the shape of my function is going to be pointing downwards at the end, which means it starts up and it finishes down. So the shape of my function is going to be like this. The second piece of information is my y-intercept. So what's my y-intercept going to be? That's going to be at y equals a plus 6. And next I'm going to try and find the roots of my function because they didn't actually give me a domain, so I can't do an input-output table. So no domain, no input-output table. So that means we need to solve x cubed plus 2x squared minus 5x minus 6 equal to 0. Now we do have a trick for a trial and error. Whatever numbers you try must be factors of minus 6. So we sub in factors of minus 6. Because if there's an integer factor here, it must divide into the last number. So we're going to try plus or minus 1, plus or minus 2, plus or minus 3, and we can try plus or minus 6 if we don't find it before that. So that's how we limit the options. So when x is equal to 1, we get 1 cubed plus 2 by 1 squared minus 5 by 1 minus 6. Which is, let me just put it into my calculator, 1 cubed plus 2 by 1 minus 5 by 1. Oh, I'm doing it all in the power by accident. 2 by 1 minus 5 by 1 and minus 6. Okay, so that gave me 2, and that's not a root. So we'll try minus 1. Just go back and change all these guys to minus. Minus and minus, and I'll just double check that I did that right. Oh yes, this one should be squared. See, because I know the answer. And minus 10. And this should have been 8 minus 5. Okay, I typed it in wrong. Okay, so when x is equal to 1, we do indeed get 0. We can't, I'm not going to use that one. And when x is equal to 2, we sub it in, we actually get 0 again. So 2 cubed plus 2 by 2 squared minus 5 by 2 minus 6. Come back nice and quickly. You can't see that, sorry. And we get 0. So that gives us 0. And we can be lucky, and they might all be integer solutions. And I'm just going to tell you the last one is minus 3. So minus 3 cubed plus 2 by minus 3 squared minus 5 by minus 3 minus 6 also gives us 0. So we have our 3 roots. We have our 3 roots, and they are at x equals minus 1, 2, and minus 3. So when I sketch the graph here, I need to go up as far as 6, and I need to go between minus 3 and 2 at the very least. How far down do I need to go? It doesn't matter. It doesn't matter because we're only sketching the graph, which means we need to try and do this within 5 minutes. Sketching graphs don't give a lot of marks. So sketching the graph here, we've got a minus 3, minus 2, minus 1, 0, 1, and 2. Those are going to be my roots. And I need to go up as far as 6 for my y-intercept. One, 2, 3, 4, 5, 6. Let's put in the important points. There's my y-intercept, and here are my x values, my roots. And I know that I'm finishing pointing down. So when I sketch the graph, I start up. How far down do I go? As far as I feel like. You could sub in minus 2 and find out how far down it should go, but there won't be any extra marks going for that, because it's just a sketch. Be aware of the language that they use. If they say draw the graph, there's more marks going for it than if they say sketch the graph. Sketch the graph is usually just worth 5 marks. So sketch. If fewer marks than draw. And there we go. So the shape, the y-intercept, the roots, these are the things they will be looking for. Those three things, they need to see them on your graph. Correct shape, correct y-intercept, correct roots, and you'll get full marks. Okay, thank you.